Hello students, welcome to this session on quants. We are focusing on section 4 of your notes, which starts on page 72 of your notes, and this comprises the algebra section. And as you can see, listed here are various objectives which we are going to achieve by the end of this section, and you can go through them, but for now we'll be focusing on identifying and simplifying algebraic expressions. If we turn to page 73, it starts off with what is algebra, and there's a statement here which says that algebra is the area of mathematics that generalize the facts of arithmetic. And an example is given where an arithmetic expression comprises numbers only. So here you only see 3 plus 2 equals 5, and actually that is an arithmetic equation because it's got an equal sign. And this here is an algebraic equation involving variables x and y and the number 2. But let's discuss an example that may give you a better understanding of what algebra is and what is meant by generalized. Now, if I had to ask you to draw a rectangle, you can draw your rectangle. I'll draw mine. So that is the rectangle that I have drawn, and along similar lines you would draw your own. The rectangle that I have drawn has a length of 3 centimeters and a breadth of 2 centimeters. So if I had to write an equation for, or an expression for the perimeter, so the perimeter of this rectangle will be 2, that's the breadth, plus the length, plus 2, the opposite sides of a rectangle are equal, and that's going to be 3. So that's an arithmetic expression that expresses the perimeter of this rectangle. And if we are to evaluate that, we are saying we are evaluating this arithmetic expression, and if you add up all these numbers, you're going to get the number 10. Now, along similar lines, what you would have done as well, you would have drawn a rectangle as well. I don't know what the length is, and because we are all in different places now, our lengths would all be different, and the lengths of your friends would be different, and the breadth also would be different. So yours could have been of length 5 centimeters and breadth 3 centimeters, and your friends could have been of length 4 centimeters and breadth 2 centimeters. So if there are 50 students in this class, we may get 50 different rectangles of different dimensions. But if I had to describe it in general, I would say that the rectangles that you'll have drawn have a breadth of x centimeters and a length of y centimeters. And if I had to write an expression for the perimeter, then the perimeter would be equal to x plus y plus x plus y. Opposite sides of a rectangle are equal. And if I had to evaluate this arithmetic expression, this is now an arithmetic expression, a algebraic expression, because this is an arithmetic expression. You see it has only numbers, but this has variables. So I've got one x there plus another x, that would be 2x and y and another y, 2y. So the difference here is that this is more generalized. Okay, and algebra allows us to generalize things, and this is very specific to one of the rectangles, which is mine. Okay, but I have described all of your rectangles by this one algebraic expression which can be evaluated to that, and depending on the values of x and y, we can evaluate it further to the perimeter of each one of your rectangles. So that is what is meant by this word here. It generalizes the facts of algebra. So that was a way of explaining what algebra is about and how the idea of generalization comes in. Going further down your notes, page 73, I suggest you read that, which has to do with how algebra is used in real life. Page 74 is for your reading as well. Page 75, please read over that. And let's come to page 76, which has some examples. And if you look at the first example there, you have simplify 3x plus 7x minus 2x. And the first thing that you note is that that is an arithmetic expression or an algebraic expression. So that is, yes, it is an algebraic expression because it has numbers and variables. So if you look at the first one there, again, you have, that's number one, 3x plus 7x minus 2x. Right, so this is an expression. It is not an equation because it does not have an equal sign. So it's an expression. Now, if you look at it here, you can see we have 3x, 7x. So the terms are very, very similar. Okay, and that is also a very similar term. So if you had to simplify this here, you are going to end up with 3x plus 7 is 10x minus 2x. You are going to get an answer of 8x. Now, if you note in your notes, it is done a different way, but I do not want to focus on that now because it is done in a method that we are still going to discuss in the pages that lie ahead. So I am just adding up like terms. Okay, I've mentioned the word like terms, so let's understand what we mean by like terms. So maybe we should start with what is an expression first of all, and recap that an expression, it can be, first of all, algebraic, which we are dealing with, or it could be arithmetic. So those are the two categories of expressions. Now, an expression, algebraic expression, has variables like x, y, z, a, b, c, etc. And we just evaluated the first expression there, which is 3x plus 7x minus 2x, giving us 8x. Now, and we use the word like terms. So in an algebraic expression, let's understand what the word term means. Right? And if we look at That's the first term there. It's 3x. But actually, it is more than a term, comprises more than that which is not visible. When I say not visible, we already know that this is a positive 3, so the plus sign is not visible here. So there is a sign. So an expression is made up of terms, and each term is comprised of a, we can call that the coefficient. Alright, so that's, and in this case the coefficient is plus 3, and it is comprised of a variable. So this is the variable, which is x, but is also comprised of an exponent which is not visible. So if we had to show everything that's visible to a term, so this is actually a plus 3, that's x, and there's an exponent here which is 0, and we know that any number raised to the power 0, sorry, that is 1, sorry, any number raised to the power 1 will be the number itself. Similarly, any variable raised to a power 1 will be the number itself. So the plus sign is not here and the 1 is not here, but that there is the general format of a term. So it has a coefficient, it has a variable, and it has an index. And when the index is 1, it is generally not shown, or the exponent is 1, is generally not shown. And when the sign is positive, it's generally not shown, thus giving us what we have here as a term. Right, so you have this term here, which is 3x, and the next term that we see there is 7x. Now, the type of term here, first of all, are very similar. The only difference is the numbers, the coefficients, and most importantly, the exponent is the same. So what is the exponent here? Yes, the exponent is 1. So when the variable are the same and the exponents is the same, we say these two now are like terms. And when you have like terms, we can now simplify like terms in an expression. This is the expression here. We can simplify like terms in an expression by adding and subtracting like terms. Therefore, when we did this here, we added like terms and we subtracted that to give us that. So in an algebraic expression, you can add and subtract like terms. Now let's do an example, right? So if you had, this is an example. If you had 5x plus 9x minus 2x, so you're going to get 5 plus 9 is 14 minus 2, that's going to be equal to 5 plus 9 is 14 minus 2 is 12. 12 x. Example 2, if you had 3x minus 5x plus 2. So this is an algebraic expression. That's a term, that's a term, that's a term. So surely these are like terms, but what about this? Okay, so in the form of a term, that is really plus 2x to the power naught, because x to the power naught will give you 1. That's how you get your 2. So these are like terms, but this is not like these terms. Therefore, here, if you have to simplify that, 3x minus 5x is minus 2x, and we cannot add those two. So we have done 2 examples there. Now let's take it further and look at your second example here. You notice there you have 3x plus 2y. Now that's a term in the variable x, and that's a term in the variable y, so you cannot add them, so that cannot go further, and that is the explanation there. Let's look at this here. Number 3. What do you think about that expression? Okay, it is a arithmetic expression. An algebraic expression, not an arithmetic expression. Right, let's copy it down. X plus 7x plus x squared. Alright, so this is a term where the variable is being x. This is also a term in the variable x, and this is a term also using the variable x. But are they like terms? Remember, for terms to be like, the variable needs to be the same and the index needs to be the same. So these two here are like terms, and therefore we can add them up to give us 8x. That is not like these terms, so that will remain as x squared. Right, so we have simplified that equation to that. Now if you come down to your exercise 4a, I do not want to tackle that exercise now, because if you look very clearly there, although it says simplify the following expressions, those are actually equations by virtue of the equal sign. So we are focusing just on simplifying expressions now, and we won't deal with the equation at this point in time. If you come to 4.1, and if you notice 4.1 now, which is towards the bottom of the page, add the following polynomials. Now what do we mean by polynomials? Okay, let us understand what that means. So a polynomial is an arithmetic expression. What? It is an algebraic expression with 2 or more terms. So if you have, say for example, if you look at the first one there, and you have just 2x squared. Now that is a monomial. Monomial means singular. You just got one term. And just to repeat, can you see the term? It's got its coefficient, it's got its variable, and it's got its index there. So that's a singular term, and a singular term does not constitute a a polynomial because there needs to be 2 or more. So 2x minus 5x, okay, that there is a polynomial. All right. Now this particular section here has to do with adding of polynomials. All right, and what is given there is a list of 3 polynomials in number 1. So if we had to copy down those polynomials, let's try to get that for us to see here. You have 2x squared minus 5x, and you have another one which is x squared plus 4, and you have another one which is minus 7x plus 8. So actually there are 3 polynomials here. So those are the 3 polynomials, and that we can call them binomials because they have 2 terms. The type of polynomial here is binomial. If you got 3 terms, it will be called a trinomial, but each one has only 2 terms. 2 terms. So this section here asks you to add. So you have to add all these polynomials. There are 3 of them, you got to add them up. Now the rule that we follow for adding polynomials is that we add like terms. Now which terms are like? The first one here is at the variable x of the order 2. So that's a variable x of the order 2, which means that these terms are like. Here there is nothing of the order 2 in the variable x, so there is no term alike in the third binomial. So if we had to add this here, we'll add 2x squared to 1x squared, which will give us 3x squared. There is no x squared term here. Here this is a term in x, so we got minus 5x, nothing here, and you got a minus 7x. So minus 5x added to minus 7x is going to be minus 12x. There are no more terms here because we've added both of them. Here is the term 4, no number here, and 8 in there. So you get plus 12. So let's go over it again. 2x squared plus 1x squared is 3x squared. There was no x squared here. Minus 5x added to minus 7x is minus 12x. There's no numbers here. There's no term with numbers only here. Here is a term with a number, and there's a term with a number on it. So 4 plus 8 is 12. Let's look at the next one. That was number 1, by the way. Number 2 is x squared minus 3 plus 1 minus 2x squared plus 7 minus 5x minus 2. There again we have here term. This is a actually it looks like a trinomial, but actually it's a binomial because this needs to be simplified first. So let's just simplify this because they are like terms here. So that's x squared minus 3 plus 1 is minus 2. So that is simplified. Now if we look at this here, and if we had to add similar terms, so there is the x squared minus 2x squared, so it's going to be minus 1x squared, and there's no x squared there, so it's going to be minus 1x squared. I didn't put the 1 there. The next thing here is there is no x term here. There is no x term here, and there is only an x term there, so there's nothing to add to it. It's just going to be minus 5x. The number here is going to be minus 2 plus 7 is plus 5, plus 5 minus 2 is going to be plus 3. Okay, let's look at number 3, which is a squared minus 4a minus a minus 5 and 2a plus 7. Right, so the only difference between this type of expression and those is that the variable has changed to a. So it doesn't matter whether it's a, b, or x or y. The same principle will follow. So let's add the terms involving the a squared. So there's an a squared here. There is no a squared there and no a squared there. So there's going to be nothing to add. So we're left with a squared. If we go to the minus 4a, so you got minus 4a there, and minus a is going to be minus 5a, and adding 2a to it is going to be minus 4 minus 5a plus 2 is going to be minus 3a. And any numbers here? No. And number here is 5, minus 5, and plus 7 is plus 2. That was number 3. Number 4, 2b squared Okay, so this has 3 terms, so it's called a trinomial. That's got type of polynomial is a trinomial. This got 2 terms is a binomial. This got 3 terms, so the type of polynomial here is that it is a trinomial. And let's look at like terms here. So if you're looking at the b squared there, you got 2b squared minus 1b squared, so you got 1b squared minus 4b squared. Your answer is going to be minus 3b squared. 2b squared minus 1b squared is 1b squared. 1b squared minus 4b squared is minus 3b squared. Let's look at the b's, terms of involving b's. So you got minus 4b and a minus b there, that's minus 5b, and a minus 2b there, that's going to be minus 7b. And the number here is 1, no number here, plus 6, which is going to be plus 7. Okay, and if you work out the last one, I'll leave you to work out that. Give you a few minutes to work out that. And let's see what answer you come to. So you can work while I write. Okay, are you done with that? Let's check your answer. So this is a binomial, trinomial, trinomial, and if you look at the highest order here is b squared. So there's no b squared here. So we start from here. There's b squared, and add another 2b squared. So that's going to be 3b squared. B minus 2b plus 1b is a minus b, plus 2b is a plus b, and here 5 plus 4 is 9, minus 9 is 0, so you do not have to write anything there. I hope you got that answer. So we have now finished with all these practice exercise. Well, we've done it together, and come to the end of the session on simplifying expressions. Our next session has to do with multiplication of algebraic expressions, which we will do in our next session. But what you will have to do as an exercise now, which we will mark at the beginning of the next section, is the balance of the exercise of 4.1 involving simplification of expressions. Okay, bye until the next lecture.